Hello, these are the notes for Monday, March 23rd, 2020. Today we're going to talk about properties of logarithms. So since logarithms are essentially just exponents, it kind of follows the same properties. So if we recall our exponent properties, when you're multiplying two things of the same base, you're going to add your exponents. If you're dividing two things of the same base, you're going to subtract your exponents. And then we have this power property. So anytime you have a power raised to a power, then you're going to multiply your exponents. So logarithms and exponents are inverse functions, so they follow similar properties. So with our logarithms, we have properties that allow us to either condense or expand logarithms. We're going to have to condense our logarithms in order to solve logarithmic equations. So that's why we're going to talk about properties of logs today. So your product property, which is this first one here. So these things can go back and forth. So the left side of this is what we would call the condensed version. And then the right side, this is the expanded version. So if you have the condensed version, which is this is going to be the one that's going to help us solve our equations, you can expand those out. So anytime you have a log and you're multiplying two things together, you can expand that out to two logarithms, and those logarithms are being added. So that kind of follows the property of when you're multiplying the same base, you're going to add your exponents. So that's why this multiplication turns into an addition of logarithms. And then similarly, whenever you are dividing two things of the same base, so if we're taking the log and we're dividing the things we're taking the log of, you can expand that out to two logarithms, the top one, the log of the top thing minus the log of the bottom. And then this is what we call our power property. So in the condensed version, we want to have things raised to powers, and in the expanded version, those powers that were on the thing you're taking the log of actually come out front as a coefficient. So when you go to condense it, so like I said, this would be the expanded version. When you go to condense it, what you're going to do is you're going to take the coefficient out front and you're going to bring it up as an exponent on the thing you're taking the log of. Hopefully this will make sense when we do a few examples here. And that's what we're going to do today. We're just going to practice condensing and expanding our logarithms, and then tomorrow we'll actually solve equations with these. Okay, so these first few examples here are how we condense down to a single logarithm. So you want to kind of do it in two steps. If you see that you have coefficients out front, the first thing you want to do is you want to bring those coefficients up as exponents. So this would turn into log base 8 of 6 to the 12th power minus log base 8 of 5 to the 2nd power. And then to condense that even further, you want to write it as a single logarithm. So you write down the word log one time. And since we are subtracting these logarithms, that means we're actually dividing the things we're taking the log of. So it turns into a fraction, 6 to the 12 over 5 squared. If you can easily simplify those, then go ahead and do it. This one, 6 to the 12th, is a pretty big number, so this is fine to use as the condensed version. Okay, and the second one here, again, you're going to take any coefficients you see and you're going to bring them up. So here's a coefficient, here's a coefficient. Bring those up as exponents. So write it as log base 8 of x to the 6th plus log base 8 of y to the 4th. And since we're adding those logarithms, we're actually multiplying the things that we're taking the log of. So write it as a single logarithm, log base 8 of x to the 6th times y to the 4th. So your addition turns into multiplication. Your subtraction turns into division. Okay, and then here's one more. Let's see, there's so many we got. Two more on this page. So why don't you pause the video, try those two, and then come back. Condensing this one, we're going to take the power of 2, put it up on our x, take this 6, put it up on our y. So it turns into log base 2 of x squared minus log base 2 of y to the 6th. Condensing it further, you want to write it as a single logarithm. Since the logs are being subtracted, you're going to divide the things you're taking the log of. So log base 2 of x squared over y to the 6th. This one turns into log base 2 of u cubed plus log base 2 of v to the 9th. Condensing it further, addition is going to turn into multiplication. Log base 2 of u cubed times v to the 9th. Okay, now expanding our logarithms. So we want to expand these out to either addition or subtraction of logs. So this one here, I see that I have two things. I have an x to the 4th and I have a y. So that means since I have two variables here, this is going to be 2 logarithms when I expand it out. The first thing you have to do is simplify this power of 2 on the outside. If you remember back to your exponent properties, anytime you have a power up on the outside, this gets distributed to all the powers inside the parentheses. So I'm going to make that log base 2 of x to the 8th over y squared. And then we can expand it out. So since we are dividing, this is going to turn into a subtraction of logarithms. So the log on the bottom is the one you're subtracting. So log base 2 of x to the 8th minus log base 2 of y squared. And then the expanded version, you are not going to see the exponents. You're going to see them out front as coefficients. So the last thing to do is go ahead and bring those coefficients or those exponents out front as coefficients. So 8 log base 2 of x minus 2 log base 2 of y. And then this would be your fully expanded version. Okay. This one, I'm going to rewrite this one because we need to see the exponent on everything. So whenever you have a root, you want to rewrite that as a rational exponent. So we solved those types of equations before where we bounce back and forth between radicals and rational exponents. Rational exponents are helpful for some things, and this is one thing that we're going to use it for. So we need to rewrite this square root of a. So this is going to be log base 2 of c to the 4th. And remember, whenever you have roots, it's the power over the root whenever you're dealing with these radicals. So this is a to the 1/2 because a was to the first power and it was the square root. Okay, we are multiplying two things here. We have two factors, so that means we can expand this out to 2 logarithms that are being added. So log base 2 of c to the 4th plus log base 2 of a to the 1/2. And then the fully expanded version, you want to bring those exponents out front. For log base 2 of c plus 1/2 log base 2 of a. So anytime you have a radical, just make sure you change it so you have a rational exponent, and then you can work with it. All right, so here are 2 more. Why don't you guys pause the video, try those on your own. Okay, rewrite this one. first so we can see all the exponents. So I have 1, 2, 3 factors in here. So this means this one's going to expand out to 3 logarithms. So log base 9, that's a 9, of w cubed, u to the 1/3, v to the 1/3. So now we have all of our exponents. We're going to expand this out to our 3 logarithms. So log base 9 of w cubed plus log base 9 of u to the 1/3 plus log base 9 of v to the 1/3. And then the last step, which when you guys get really good at this, you'll skip this step and you'll bring the coefficients out front as you expand it out. Bring all those coefficients out front. 3 log base 9 of w plus 1/3 log base 9 of u plus 1/3 log base 9 of v. And then the last one, you want to make sure that you simplify this portion of it first. So distribute that exponent. So log base 8 of 12 to the 4th over 7 squared. So we have division here, so this is going to expand out to subtraction. So log base 8 of 12 to the 4th minus log base 8 of 7 squared. And then the last thing, bring those coefficients out front. And that's our fully expanded version. And that's it. So that's the lesson for today. So I'm attaching a practice sheet for you. Make sure you practice these. I'm not collecting this assignment today. It doesn't mean that you shouldn't practice. At a minimum, do the odds. Make sure that you know how to do these because we're going to be using this tomorrow when we solve our logarithmic equations. So, okay, have a nice day.